This is the walkthrough video for PCTC 2021-2022 round 2, question 7, playing catch up. So I think this question is actually pretty interesting, but essentially we have to simulate this game where two robots are just playing, and we have to figure out how long it takes until the second robot catches up to the first robot. So as always, the first thing to do is to take in our inputs, which are going to be x, t, and y. You can take them in however you want, but this is how I'm going to take them in. Okay, so I've got my three inputs. Now I want to keep track of the distance that the two robots are, Ravina and Alan's robots. So I'm going to create a new variable called R for Ravina and A for Alan. And both of their robots start off at 0 distance. And now I want to simulate the game. And so I'm going to set time equal to 0 to begin with. Then I'm going to have an infinite while loop. And within this while loop, I'm going to keep incrementing Ravina's distance value by x, because that's how much the robot moves per hop. And I'm also going to increment Alan's robot's distance value by y. But I should only do this if the current time is past or equal to the time where his robot actually begins, which is t from our input, because the question tells us that Alan's robot sets off t seconds later. So only if his robot has set off are we going to increase his distance. And so now time is increased by 1 because all of these robots have increased their distance. So let's increase time by 1. And finally, we need to check to see if Alan's robot is caught up to Ravina's robot. So if Alan is bigger than or equal to Ravina, then let's print off time, because it wants us to calculate how many hops Ravina has had until this happens. And because one hop happens every second, the value of time is equal to the amount of hops that Ravina has made before Alan has caught up. And then after this is done, like after Alan is caught up with Ravina, the question is ended, the code is ended. So let's break out to this while loop, and then we can submit our code. But yeah, you can see here, we only get 8 out of 10. We want 10 out of 10, right? So it seems that the error is on the last test case, and it says time limit exceeded. So that suggests to me that this code is too inefficient. And if you go back to the question, it does kind of explicitly say they are keen to test out their code for some large values of up to 10 billion. And we can also see 10 billion in the constraints. So clearly, just simulating the code isn't going to work. That's not the most efficient solution. It does pretty quickly get us 8 points, but we want 10. And this is not how we get 10, unfortunately. And I think this is where it's interesting, because now we have to come up with a solution that's way more efficient. And this solution actually ends up being much more elegant. I think it's only 3 or 4 lines of code. But I can pause the video and have a think about how you think we might be able to code this. Actually, let's save that code. Yeah. So essentially, if we don't want to just simulate things, because simulating takes time, running this loop 10 billion times will take too much time, how else can we do this? And the answer is usually pretty much always just going to be maths. Can we just do one computation that kind of simulates maybe 1,000 seconds within one loop? Or can we just like avoid having to run a loop 1 billion times or 10 billion times? The answer is yes. So what we can do is we can calculate how far Ravina has moved before Alan begins moving. So let's set that as R. So R is going to be equal to the distance she moves per second, or her robot moves per second, multiplied by T, because T is when Alan begins moving. So R is now the value of how far Ravina's robot has moved before Alan starts moving. Now when Alan starts moving, he's going to begin to catch up to Ravina's robot. And we can simulate this, but that's, as we saw, computationally intensive. So what we want to do instead is figure out maybe how much does Alan catch up with Ravina every second. Because if he catches up with her, so if he moves like 10 meters a second and Ravina moves 5, we don't really care about the fact that she moves 5 and he moves 10. We only care about the fact that Alan moves at a faster rate. Alan moves 5 meters per second faster than Ravina. So Alan catches up to Ravina at 5 minutes per second. Every second that passes, Alan is 5 meters closer to Ravina. And so let's calculate that. Let's calculate the difference to be equal to y minus x. And that's just what I just said. It's basically how much Alan catches up with Ravina each second. And so what this allows us to do is we can now calculate how much time it takes until Alan has caught up with Ravina, because that's just going to be R divided by diff. Right, this sum is basically how many seconds it takes from when Alan starts moving to when Alan catches up with Ravina. And we want the absolute time, because we want to figure out the amount of hops that Ravina has done, which includes all of the hops from before Alan started moving. So that's going to be t. So t plus this value is our answer. So we can just go ahead and print that off. But before we do that, I think there might be an error, because r divided by div is going to be a float. It's going to be a decimal number, whereas we actually want it to be a whole integer. But we can't just do this, because that's going to print like that's not necessarily going to be correct, because we want the point in time when Alan has passed or reached Ravina. So if r divided by div is equal to 3.8, well, it's going to take Alan a full 4 seconds before he passes or reaches Ravina. And so we don't want to just add 3, which is what this would do. We want to add 4. We want to round up, because we need to make sure that we at least reach Ravina. So we always need to round up our time to the next whole integer. And to do that, let's just import from math, let's import ceil. And that's how we can round up. And so instead of writing int here, we can write ceil, and this will round up our r divided by diff value. So if this value is already an integer, if it's 3.0, it's going to keep it at 3. But if it's anything like 3.1, 3.4, whatever, it's going to round that up to 4 and then print off t plus that rounded value. And this should get us our final 2 points, because our code should run super duper quickly. But yeah, that's this question. I love this question, because you can just kind of do the more basic simulation and still get most of the points. If you really want to squeeze out the extra performance, you have to find this elegant solution, which is only 5 lines of code, and I love it. If this doesn't make sense to you, then of course, like, go mess around with the maths, go draw images or number lines to help you kind of understand this, and why this matters. We've essentially abstracted all of the detail from the question to only contain what we actually want, which is the difference, how much Alan catches up with Ravina each second. That's all we care about, and that's what we're saving. And if we go back to our original code, which was this, a couple of errors you might have come across if you initially coded this and it was still wrong, is maybe you had your time added in the wrong place. So you need your time added after so in this case, you need your time added after you've done all the checks for adding distances and stuff, but you need it before you've done the check to see if Alan's passed Ravina. And that's just because of the nuance of the question when it says that it takes a hop at the end of every second, because we only want to check whether Alan should start moving before the second has ended, but equally, they only move once the second has ended. And so you have to be very careful in terms of where you put time, or you'll get an off by 1 error. And a very easy, quick way to check that is just to enter the example input and check to see if your answer is maybe 5 or if it's 7. And if it's 5 or if it's 7, you have an off by 1 error, and you can quickly try and figure out where that error might be. And in this case, it's probably because your time increment is in the wrong place. But yeah, that was question 7. Hope you enjoyed.